Oh, good afternoon. Millions of years, where did the idea come from? We live in a world today where the vast majority of people believe in millions of years, and I've had the privilege of speaking in 22 countries on the creation evolution issue, and I found that the majority of Christians believe in millions of years. It varies from country to country, but most Christians don't know what to do with this millions of years, and I've found as a result of my time in seminary and a lot of reading and participation in the Evangelical Theological Society that most of our theologians in our evangelical seminaries have accepted the millions of years or lean that way and don't think it really matters. And I think this is a huge mistake. The millions of years supposedly comes from the geological record, and that record is represented in textbooks and in museum displays with charts like this. You've probably all seen those. It's an evolutionary interpretation of the rock record that we start out with simple bottom-dwelling sea creatures, and even before that, microscopic creatures, and then they evolve into fish, amphibians, reptiles, mammals, birds, and people. And the evolutionists say today that from the first living cell up to the present is 1.9 to 3.8 billion years. Just an incomprehensible amount of time. Well, that's not what people have always believed. So where did that idea come from? So that's what we want to look at in this session. And before we do, I want to look at a couple passages of Scripture and then define some terms. In 2 Corinthians chapter 10, Paul says, "For the weapons of our warfare are not of the flesh, but divinely powerful for the destruction of fortresses. We are destroying speculations and every lofty thing raised up against the knowledge of God, and we are taking every thought captive to the obedience of Christ." So Paul says we're in a war. It's not a war of spears and arrows or missiles or bullets. It's a war of ideas. Paul calls them speculations. The King James translates that Greek word imaginations. And Paul says these are high and lofty ideas. They sound really intellectual, and they're raised up against the knowledge of God, and therefore they're raised up against His Word, which is where we get the knowledge of God. And Paul says we as Christians, we need to take every thought captive to the obedience of Christ, which means to take every thought captive to the Word of God. Then in Colossians chapter 2, Paul says, "See to it that no one takes you captive through philosophy and empty deception, according to the tradition of men, according to the elementary principles of the world, rather than according to Christ." Paul said, be careful. There are ideas out there that are the philosophies and traditions of men, and they're contrary to the teaching of Christ. Now, Paul did not give warnings in vain. He knew that it was a very real possibility that Christians could be taken captive by false ideas. In fact, most of Paul's letters are written to churches that were taken captive by the traditions and philosophies of men. And so Paul warns about speculations and philosophies, and as we go through this history, we're going to see that that's what's happened to the church. The church has been taken captive by lofty ideas that sound really intellectual, in our vernacular, really scientific, but in fact are contrary to Christ and His Word. Now, how many of you have ever heard a statement like this? Evolution is science and creation is faith. Or evolution is science and creation is religion. Anybody ever heard that? That's a mantra of the evolutionists. And whenever I hear that, I know that either the person doesn't understand the nature of science, or they are deliberately trying to confuse us. Because to understand this origins question of evolution versus creation, we have to understand that there are two broad categories of science. I like to call them operation science and origin science. It's a critical distinction. Operation science is what we normally think of when we think of science. It uses the so-called scientific method, which can be defined this way: the use of observable, repeatable experiments in a controlled environment, that's usually in a laboratory, to understand how things operate or function in the present physical universe in order to find cures for disease or produce new technology or put a man on the moon or put a cell phone in everybody's pocket. So operation science is what we normally think of when we think of science. We also call this experimental science or observational science. And it's what most scientists are involved in the fields of most of biology, chemistry, physics, medical research, engineering research are all fields of operation science, experimental science. But that kind of science won't answer the question, how did the Grand Canyon form? Because you can't recreate the Grand Canyon in the laboratory. It's a historical question. You're standing there at the north rim of the Grand Canyon, you see that big hole in the ground, and you want to know what happened in the unobserved past to produce what I'm looking at in the present. Experimental or operational science also won't answer the question, is the body under the slab in the floor of Westminster Abbey in London that has the name Charles Darwin on it, is that really Charles Darwin? Well, you can't lift the lid and raise him from the dead and ask him. You can't do a scientific experiment to recreate him in the laboratory. It's a historical question. And for historical questions, we need a different kind of science, origin science, which uses what I call the legal historical method, which can be defined this way. The use of reliable eyewitness testimony, if any is available, and observable evidence to determine the past unobservable, unrepeatable event or events which produced the observable evidence we see in the present. So, if I'm standing at the north rim of the Grand Canyon right here, and if there was a Hopi Indian standing next to me, and he said, I was standing right here where we are now at the north rim, and I saw the canyon form, well, then I'd have an eyewitness. And if I could really question him and find out, he's not smoking some weird plant, he's not drinking some weird liquid, he's a man of sound mind and character, then I would have a reliable eyewitness. But we don't have any reliable human eyewitness for the formation of the Grand Canyon. So we're left with the observational evidence, the rock layers, the erosional features, the fossils, and we're trying to figure out, okay, what happened in the past to produce those layers and that big hole in the ground? So origin sciences would include historical geology, paleontology, archaeology, cosmogony, trying to figure out how the universe came into existence, or forensic science, which is what detectives use in criminal investigation. So we can also call this historical science. And it's exactly, in principle, it's exactly what my son would do. He is a sheriff's deputy down in Florida. And if he got a call on his police radio, Mortensen, report to 2417 Johnson Street. We've been told there's a dead body in the living room. We want you to figure out what happened. Well, if he's a good cop, when he gets to the scene, he's going to investigate the circumstantial evidence, the observable evidence, but he's also going to go talk to the neighbors and see if he can find an eyewitness. Did you hear something? Did you see something? He's going to check to see if the door's been busted open or there's a gun or a suicide note, because he wants to know, was this suicide, murder, or death by natural cause? And so that's exactly what the geologists and the paleontologists are trying to do. They're looking at the world as it is right now, and they're trying to figure out what happened in the past to produce those rock layers and fossils. Most evolutionists either don't understand this distinction or they don't want to let the public know that there's a distinction. And so they will give examples of operation science and then lead people to think that the geologists are doing the same thing and science is very trustworthy. But one evolutionist, who's a very famous one, died a few years ago, does recognize this difference. His name was Ernst Mayr. He was professor of zoology at Harvard University and an atheist for most of his life. He said, evolution is a historical process that cannot be proven by the same arguments and methods by which purely physical or functional phenomena can be documented. So the question of creation versus evolution is not in the realm of operation science, experimental science. It's in the realm of origin science. And they are both stories to try to reconstruct the unobserved past. The difference, the vital difference is that the evolutionist has no eyewitness testimony, but the creationist has the eyewitness testimony of the Creator, who was there all the way through history and has told us some key events to help us understand our world. So let's look at this idea of millions of years and how it developed. It wasn't the idea of just one person. There were a number of people, and I'm going to mention 8 of the most influential people. One of them was Comte de Buffon. He was a French scientist who was knowledgeable in a lot of areas of science, which was possible in the 18th century because we didn't know very much compared to what we know today. And in 1778, he wrote a book called Epics of Nature, in which he imagined that the earth was once a hot, molten lava ball, and it slowly cooled over about 75,000 years and was transformed to become the planet that we live on today. Now, he never observed that happening. He didn't do a scientific experiment to prove that happened. Well, he did some scientific experiments with metal balls in his laboratory, different kinds of metals, heated them up, and then watched how long it took for them to cool down. But of course, he was making a massive assumption that the Earth is just a simple metal ball. Then there was Pierre Laplace. He was an astronomer in France, and in 1796, he wrote Exposition of the System of the Universe, in which he imagined or speculated that the solar system was once a huge spinning gas cloud. It flattened out, and then it developed rings, and those rings evolved into planets. And his view became known as the nebular hypothesis, and that is the idea that modern evolutionary astronomers have for the origin of our solar system. But at the time, this idea was rejected by most scientists because they looked at the solar system and considered it to be too amazingly designed. But he said that process took untold ages to form that solar system. Then there was Jean Lamarck. He was a zoologist specialized in the study of shell creatures, and he wrote in 1809, Philosophy of Zoology, in which he proposed a theory of biological evolution over long ages, that all the different plants and animals were related to a common ancestor. And in 1809, most scientists rejected the idea of evolution. They saw the incredible design of living creatures. But this was a seed idea preparing the way for Darwin's work in 1859. Now, none of those people were geologists, but Abraham Werner was a German mineralogy professor and a very, very popular teacher. Many of the 19th century's greatest geologists were his students. And in 1786, he wrote Short Classification and Description of the Various Rocks, which, as the title indicates, was largely descriptive of the different minerals. But he had a short section in the book where he gave his theory of Earth history. And as he looked at the sedimentary rocks there in southeast Germany that are just like the sedimentary rocks we see in the Grand Canyon or in the road cuts around Cincinnati or on your way down the freeway to Louisville, he imagined that those were the result of a slowly receding global ocean over about 1 million years. Now, he didn't observe that ocean doing that. He didn't do an experiment in the laboratory to show. He was speculating or imagining about the unobserved past. He didn't pay very much attention to the fossils, however, but they are key to unraveling that history. Another man at the same time was James Hutton. He was up in Scotland, and he studied medicine at the university, took over the family farm after graduation, but his real love was rocks. And in 1788, he wrote a journal article, and in 1795, he wrote a book by the same title, Theory of the Earth. And he had a different view from Werner because he saw evidence of volcanic activity up there in Scotland. And so as he observed things, he saw that the wind and the rain were eroding topsoil and little particles of rock slowly, and those particles would be carried to the rivers, and then the rivers would dump their sediments on the ocean floor. And then he imagined that the internal heat of the earth would harden those sediments, and then through some convulsion raise them above sea level. And they would become new continents. And so he said, the continents are slowly being eroded into the oceans. The oceans are being lifted up to become new continents, which will slowly be eroded into the oceans, will be lifted up. And so he said, Earth history is going in a cycle. And he said, I can see no evidence of a beginning in the rock record. Now, he didn't pay a lot of attention to the fossils either. But somebody who did was Georges Cuvier. He was a French comparative anatomist and paleontologist. And in 1812, he published a book, The Theory of the Earth, based on some previous journal articles. And as he looked at the fossils and the rock layers in and around Paris, he proposed that the Earth had suffered a series of catastrophic floods of a global or continental scale separated by long periods of time. He believed in creation in terms of believing that God created the living creatures. He was very opposed to the evolutionary ideas of Lamarck. But he said after God created things, life went along for a long period of time, and then there was a catastrophic flood of a continental or global scale, wiped out many or all of the creatures living at the time, buried many of them in sediments. They became fossils. And then the earth recovered from that event. Survivors repopulated the earth. God created new creatures to repopulate. And this happened many, many times in earth history, separated by long periods of time. Another man that had a similar idea was William Smith. He was an English drainage engineer and a surveyor. And in the course of his work of helping to build roads and tunnels and bridges and canals in Wales and England, he saw the rock layers exposed and the fossils and became fascinated with them. He became known as the father of English stratigraphy because he was the one who developed the method of using fossils to give relative dates to the rock layers. Not absolute dates of any numbers, but to say that this rock layer was older than this other rock layer based on the fossils in them. And that method of using fossils to give relative dates of younger or older is still used by evolutionary geologists today. He held to a catastrophist view similar to Cuvier. Finally, I want to mention Charles Lyell. Lyell was born the year that Hutton died, and he built on Hutton's ideas. And in 1830, he published the first of his 3 volumes of Principles of Geology, in which he argued that the earth had never suffered a catastrophic flood of a continental or global scale, but that the real agents of change in earth history are just slow, gradual change. Slow, gradual erosion, slow, gradual sedimentation. You know, an earthquake here, a volcano there every so often, but no bigger or more powerful on average than the volcanoes and earthquakes we see today. So let's summarize then. In the case of Buffon, he proposed or speculated about a cooling earth over about 75,000 years. Although historians of science have studied his unpublished writings, and he clearly believed in 1 to 2 million years for the earth. Laplace proposed the nebular hypothesis for the origin of the solar system over long ages. Lamarck proposed a theory of biological evolution over long ages. Werner said the rock layers with their fossils were the result of a receding ocean over 1 million years. Hutton became known as a uniformitarian. He believed there was no beginning to the rock record. Cuvier became known as a catastrophist with these major floods separated by long ages. Smith had the same view and developed the method of using fossils to date the rocks. And Lyell became the champion of the uniformitarian view, which comes from the word uniform.